Alright, so these are the moon and star questions. So, alright, for the topic. So, the first question is the moon's altitude. So, an observer measures the angle of elevation of the moon above the horizon at two different times from the surface of the Earth. Once when the angle of elevation is 10 degrees and once when it is 40 degrees. So, the first question is if the observer is standing 100 miles away from the point directly underneath the moon at the second observation at 40 degrees. So, then what is the height of the moon above the Earth's surface? And the second question is if the moon's height was measured again when it was 30 degrees above the horizon and the observer is still 100 miles away, what would be the new height? So we're just going to be measuring the height of the Earth and then we're just going to be changing the degrees. And yeah. So, the first question, since we're trying to find 45 degree or 40 degree angle here, we're going to be just finding the height here. So, we're going to be using sine of 40. I guess we're just trying to find the height, right? We're going to be using sine 40 times by 100, because that's how far we are. We're 100 miles away from the moon. So, we're saying 100 miles away from the point that's underneath, so we're 100 miles away here. So, we can approximate sine 40 to just make this easier, which is equal to about 0.64. So then all we have to do here is do 0.64 times by 100 is equal to about 64 miles, which is how far the moon is above the Earth's surface. And yeah, that's how you do that. It's really simple. You're just solving for the height there, using the distance and the angle of elevation. And then for the second question, instead of 40 degrees, we're just going to be using 30 degrees instead. Still trying to find the height, and we are exactly 100 miles away from this point underneath. So, we're just going to be using the same thing. H equals sine of 30 times by 100. So we're just going to approximate sine 30 again. You can use a calculator, whatever you want. This comes out to about 0.5 rounded, so yeah. And then all you have to do is do 0.5 times by 100, which is equal to 50 miles, which is how far the observer is away from the point right underneath. That's how far up the moon is from the observer's point of view. So, question 2 is star visibility. So, a star is observed from a point on Earth 100 miles away from being underneath it directly, and at a specific moment, the star appears at an angle of 75 degrees above the horizon, and 2 hours later, the Earth rotates, and the star appears at an angle of 30 degrees above the above the horizon. So, the star is just going to move, and we're going to see how far along the Earth's surface the observer has been rotated in correlation to the star. That is the first question, using the given information. And in the second part of the question, if the horizontal distance moved, was instead calculating using the distance to the star as 200 miles instead of 100 miles, what would be the new distance? So, to do this, we're just trying to solve, so from here, and then it's just going to move to, instead like a lower angle, like that. And we're just going to calculate pretty much this. If it moved from here to here, we're just calculating that distance. So, we're going to be using the cosine of 75 degrees, which is the initial, which we can approximate to 0.26, and then cosine 30, which we can approximate to 0.87, are the two numbers that we will be using. So we're just going to do 0.87 minus 0.26, which comes out to about 0.61. So we're going to do 100 times 0.61. So 100 times 0.61, and this comes out to about 61 miles, which is how far along the Earth's surface the observer has been moved in correlation to the star. And for the second question, it wants us to do that, except we're going to be using 200 miles instead of 100 miles from being directly underneath the star. So we already know that the cosine of 75 is already equal to 0.26, and the cosine of 30 is equal to 0.81, like 0.87. So we're just going to do again here, 0.87 minus 0.26, which we know is equal to 0.61, and then you're just going to do, instead of 100, you're going to do 200 times 0.61, which comes out to 121 miles is the distance that the star, or that the observer has been moved if we're standing further back. And the third question is the star altitude and horizon difference between two different points. So the star is observed at an altitude of 30 degrees above the horizon from a point on Earth, and then later that night the star appears directly overhead at an altitude of 90 degrees. So we're just going from pretty much this type of viewing point from here to this, being directly underneath it. So yeah, that's what we're going to try to do. So the Earth's radius is approximately 3,960 miles, and how far along the Earth's surface did the observer travel to see the star go from 30 degrees from here to here? So obviously the observer is moving this way, so it can be underneath the star. So to solve this question, we're going to be converting it to radians because we're trying to calculate the arc length since the Earth is a sphere. So I'm using 60 degrees because that's the difference between 30 degrees and 90 degrees. Since we're going from 30 to 90, we're just going to use the difference here. So, and this is equal to about pi over 3. If you remember your unit circle, that's about here. It's about here. Not halfway, just underneath that. Above that, sorry. So then we can just do the approximate of pi over 3, which is equal to about 1.05, and then we'll just do the radius of the Earth, which is 3,960, times by 1.05, which comes out to about 4,150 miles, which is how far the observer traveled to be directly underneath the star. And in the second question, it wants us, instead from going from 30 degrees, we're going to be using 45 degrees to go to 90 degrees. So we're just going to be changing the number. So instead of 60 degrees difference, this is a 45 degree difference, and the 45 degrees on the unit circle is equal to pi over 4, which is just halfway, remember. And then you're just going to do the approximate of pi over 4, which is equal to 0.79. And here we can just do 3,960 times by 0.79, and this comes out to about 3,120 miles, which is the distance that the observer traveled to be directly underneath the star.